I'm not sure that I was streaming or not on YouTube. I'm just gonna wait to see if it's streaming there. So the main thing is the not having a remove function. Not sure if there is other issues with the implementation. I think while GPT thinks, I'm just gonna do some quizzes. So the first idea that I thought, I'm not gonna do that many things today, I think, because the main thing that I'm trying to think about is new ideas on how to improve the environment. Because this is very good, like as a baseline. The goal that I have here is not really to have something that is like for beginners. It's more like the way that I view it is more like a gym where I don't have to think about it at all. So like I do all the work to set up the environment, then don't have to think about it at all, and then I just do like 30 minutes every day, and then that builds. Ideally, you should build like the muscle memory for just typing the patterns without having to think about it. And the main challenge that I have when thinking about this is that currently I have a very good idea of what needs to be done for whatever I want to build. Like I already understand how their architecture is gonna work and the design. But a lot of the times I struggle to convert that into execution because there's a lot of things about the nuance and the memory and pointers, lifetimes, these kinds of details that are very annoying. And just looking at the documentation, like, it adds friction to the whole loop. So that's the whole thing, like the whole purpose I have now. The main goal that I have is to figure out how to decrease this friction. That's what I'm trying to do. So the quizzes are somewhat good for this, and the data structure reconstruction is kind of like they are not good for this. They are good for understanding like programming concepts, I think, but they don't really hit like the stuff that I'm trying to hit. It's kind of hard to explain because it might be something to do with learning the libraries more, the core libraries that they are probably used on most of the projects. But yeah, and like the implementation here, I think is kind of bad because it's good in the sense that it forces me to like think about how this data structure is implemented in Rust, but I think it's unlikely that I'm gonna be using any of these solutions in practice. Because what I assume is that there is some library probably that's highly optimized, and it's gonna have better solutions than this, I think. And on Rust, you have like the hash map, for example, and this other stuff is part of the standard library, I think. So probably most of the time you're just using that, you're not really implementing. But like this side of exercises is good for you to understand like how these things work under the hood. So they're not useless, but they don't hit the stuff that I'm trying to hit. What I'm trying to hit more is like I have an architecture on my mind, and then I just wanna like type everything without thinking about it. Like to become unconsciously competent to that level. And it's very hard to figure out like how can I create exercises that are gonna allow me to train? Because obviously the best way to learn is gonna be to build projects. But then The issue with that is that it's not high density enough because it takes a lot of time to build a project and then it deviates from all the other stuff you want to do. So it's very slow. And I'm trying to figure out like the core patterns that happen all the time, like how to loop over things, how to manipulate strings, how to convert data types, built-in data types, these kinds of things. How can I systematically train them every day? That's the stuff that I'm gonna be spending time trying to figure out. And I think that probably the best thing to do is the first idea that I had is this here. But I think the best direction to go with is to first improve the site because I also have this other site here that I built. And I think that's whatever I do here, there's a chance that I'm going to extract the same principle or same structure, same part of the architecture on this site, and I'm just going to make it a tab here. So I think that the best way is to improve this site first. And then if that's not enough or it's not good for whatever reason, then I can think about like other ways to do it. And the first idea that I have is this, like create a closed card. Closed card is like when you have a, the way that I'm thinking about it is like I extract a pattern from a code base that I'm studying, and then I put blanks. I remove some of the parts of the code, and then the goal is for you to rewrite the implementation from that partial solution. I think that's probably a very good idea. But then obviously if I want to make it better, the goal would be like to extract from the libraries, but then it becomes a lot harder. So I think that probably as a compromise, I think I should do that manually because then it synergizes well with studying libraries. So what I'm thinking about is like I already have some idea of the kinds of libraries I want to study. So I go manually study those libraries, try to figure out like what are the most important parts, and then as I'm studying, I copy and paste some of the implementations of these patterns, or I copy the code into GPT and then I use GPT to transform that into like an exercise that captures the pattern that I'm trying to understand. That's probably the best way to go about it. Then over time, I build like another set of quizzes here, another category. And I think I have to change as well, like because this has categories, but they are all the same type of quiz. I need to figure out a way to create a different type so that is clear, like which ones I'm gonna do. Maybe another interesting thing would be like to do something similar to the Godbolt compiler, where you can see the assembly. That might be interesting as well. There's another like immediate idea that I was thinking about, where I create something that I type Rust here, and then it shows the outputs or something like this. That might be interesting as well to implement. I think that this is an error. Basically, like I remember this quiz a little bit. It has something to do with the conversion from types. So it's using a string here and integer here, and trying to create a vector that uses both by specifying this dynamic debug. And I think it's something like on how Rust, because I think both of these types here implement the debug probably as a macro. And Rust does something internally. I think that the lesson here is that it's different than C or than C++, where if you have derived classes from a base class, then you can create an array with the base class. And as long as you have pointers of the derived classes, then you can do this. But in Rust, you can't, for whatever reason. It's something along those lines, from what I remember. And then otherwise, the other thing that is weird is that this is not mutable. So, yeah, but I think it doesn't, like this operation probably, yeah, it doesn't change this. So maybe you can do that. But I think the error is because of the type here. I forgot exactly why. Unlike some trait objects, cannot be downcasted through a more concrete type. Yeah, so that's basically what I was saying. So you can't downcast a trait object to another type, except in the case of any trait. I'm gonna read the response here.
This is a good core implementation of an unbalanced binary search tree, but it needs several corrections before I consider it a strong exercise solution. The search/insertion/iteration algorithms are fundamentally right. Most weaknesses are in the type declarations, API boundaries, documentation of invariants, and especially the drop justification/test. One important naming point first. This is a binary search tree, BST, not merely a binary tree. Its entire behavior depends on ordering. Audit issues severity. What did you know is missing T red circle compiler error struct node T binary tree is missing T red circle compiler abstract binary tree T empty or binary tree missing T red circle compiler error empty or binary tree T. Drop for binary tree missing generic parameter red circle compiler error empty drop for binary tree T vec. A node missing T red circle compiler vec. A node T option self item malformed red circle compiler option self item. Escaped underscore or invalid rest if literal red circle compiler remove the backslashes all methods unnecessarily require T or in circle API design split ordered none of your blocks duplicate policies implicit or in circle invariant. Clarity document left node right node called binary tree although behavior is BST or in circle semantics rename skeleton permits or document clearly drop panic safety comments are incorrect or in circle correctness slash docs remove slash rewrite. Some test underscore drop underscore runs doesn't test iterative drop or in circle test quality added deeply skewed tree drop test underscore ref leaves unnecessary box underscore layer yellow circle style prefer as underscore ref for read reversal comparisons duplicated and contains yellow circle. Style prefer ordering slash CMP no default yellow circle API bullish implement default via new no into iterator for binary tree green circle optional nice ergonomic addition no balancing green circle expected limitation document worst case O and don't fix unless. Exercise asks if those backslashes were only introduced by copying into chat. Ignore that syntax point. The missing generic parameters are still genuine problems as stated. One, the generic declarations are currently invalid. These declarations rust struct node element T and rust pub struct binary tree refer to T without declaring it. They need to be rust struct node T element T left option box node T right option box node T pub struct binary tree T root option box node T len u size that propagates throughout. The implementation rust impl T or binary tree T end rust impl T drop for binary tree T end rust pub struct there a T stack vec a node T. This is the first thing I fixed because otherwise we're reviewing an algorithm that cannot actually be compiled. 2T or is attached to broadly currently you have rust impl T or binary tree T pub node pubflin pubfis underscore empty pubfnider. But none of those operations require ordering. Only rust insert contains need ord. This distinction matters pedagogically because straight bounds should express actual mathematical requirements. The better structure is rust impl T binary tree T pub node self pubflin self u size pubfis underscore empty self bool pubfnider self iter underscore T impl T or binary tree T pubfinsert mut self element T. Proof contains self element T bool. That's a meaningful rust lesson. Put constraints at the narrowest place that actually needs them. 3. The real invariant should be written down. Your insertion rule is rust iphone node element left else right. Therefore the tree invariant isn't simply left node right. It is all values in the left. Sub tree node element all values in the right. Sub tree node element because equal elements always travel right. That's completely valid. The tests make it clear that duplicates are intentionally supported. Rust tree insert 5 tree insert 5 tree insert 5 insert underscore EQ. Tree.len 3 so I would explicitly document that. For example, rust in a balanced binary search tree. Invariant for every node. Values in the left subtree are node. Element values in the right subtree are node. Element duplicate values are retained and inserted into the right subtree. This is much more educational than simply saying rust a basic binary tree using box because it tells the student what must remain true after every mutation. For it isn't really a generic binary tree. This is a terminology issue worth fixing. A binary tree just means that each node has at most 2 children. This structure is specifically a binary search tree because insert decides where to place an element using ordering and contains relies on that ordering to eliminate half of the remaining tree. If the exercise still enforces rust binary tree T keep it. Otherwise, rust binary search tree T would be the more accurate name. 5. The insertion algorithm itself is good. This part is one of the strongest pieces. Rust let curl self dot root while it's on node curl node. Element curl node left else curl node right curl some box new node element left none right none. It's a nice example of immutable. 12. Default is worth implementing when rust new has an obvious empty slash default state supporting rust binary tree. I32 default is idiomatic. I prefer explicitly delegating rust impl T default for binary tree T default. Self new it also reinforces that default and ordering have nothing to do with one another. 13. Into iterator for binary tree T is a good small extension your current API requires. Rust 4 tree, but you can cheaply support. Rust 4 tree with rust impl a T into iterator for a binary tree. T type item at type into iterator a T into underscore iterator self into iterator self. I classify this as optional rather than required, but it's a good example of how rust collections normally expose for iteration. Improved version assuming duplicates are deliberately allowed in the exercise API wants the name binary tree. This is roughly the version I use. Rust use stdcmp. Ordering an unbalanced binary search tree. For every node, every value in its left subtree is less than element. Every value in its right subtree is greater than or equal to element. Duplicate values are retained and inserted into the right subtree. Because the tree is not balanced, insertion and lookup are h, where h is the tree height. In the worst case, h length up obstruct binary. Node T element left, owned optional subtree right, owned optional subtree with these invariants. Ownership. Every node has exactly one owning path from root ordering. Left node right. Node size, len number of reachable nodes iteration. Each reachable node is yielded exactly who owns each subtree, where an ordered value may go, what len represents, and why traversal slash destruction require an explicit stack.
I didn't read the full answer because I think I can't really trust that much the answer based on the beginning there, where it's saying there is a compiler error or whatever. So I'm just gonna ask, why isn't there a remove function? And you are right. I forgot about the rebalancing as well. So because like there's a chance you always add values that are greater than the one that already exists. So the tree only grows only to one side, so it becomes unbalanced, which defeats the purpose of having the tree in the first place. So in order to avoid that, you have to rebalance the tree every time you insert or remove. And I think for a lot of situations, rebalancing is probably the hardest part of this. I remember from the red-black tree, that is extremely confusing and hard to create or to make it work. Especially when you want structural sharing, which means that the pointers is like copy on write pointers. I'm just gonna ask this, I'm not gonna spend too much time I'm gonna open another thread and then I'm gonna start discussing because I'm much more curious about this, how to build these improvements for the environment. And this one I remember, this has to do interior immutability. You can't do this here because RC doesn't allow mutating the value inside. So RC is reference counted pointer, because Rust doesn't have garbage collection. Garbage collection is whenever you have a program that cleans up unused memory. And some languages do this by default, and Rust doesn't do this. So they have this reference count type, which creates a pointer that keeps track of how many things are pointing to that. That makes sense. But then when you use that, you can't change the value that this thing is pointing to. And the name of this is called interior immutability. And then if you want to do that, you have to use this ref count. So from what I remember, it is like that. You would have to do like this. If it was initialized like this, then you would be able to reference and change after cloning. I don't remember if it is ref count. I'm gonna yeah, so it looks like it is. This. Whatever. Next one. Yeah, what I think I should do probably for this is actually search real implementations instead of creating my own there. Then from this real implementation, study the source code, if it is possible to see the full source. That's probably what I should do. I think I'm gonna pause probably this exercise thing, this reconstruction exercise, and then I'm gonna search for like real implementations of these data structures. Because then there is more likely like search for a repo that a lot of people use. Because then it's more likely that the implementation is already optimized, and then I can study that first, then work on reconstructing. Probably should do the instead of doing this reconstruction in the way that I'm doing there, like on two separate repos, I should just merge them. So do the thing that I was saying about the closed cards on the website. I think I should do the same thing for the data structure reconstruction. Because most of the typing is also redundant. So but to make things faster, I need to figure out like what are the key things that are hard to remember. But that's what's kind of hard because it like the thing is that it depends obviously on what you're gonna build, and the hardest part is gonna be the pointers and types, which is more an architecture thing. But I think for like reducing friction on most parts, I can build something that allows me to train the like common patterns. I think I should probably think that I should be building the exercise around should be methods or implementations for built-in types and common things that are used, like to have operations on types and conversion between types that are common as well. Hey, what's up? I think I don't see. Maybe it doesn't work because of the box, but I think that I guess it's I don't know for sure, but I think it works. So this is gonna increase by one, and the output's gonna be one. It's gonna be two. Obviously, not really sure though. Box can hold a mutable reference to the referencing beam. Or I'm doing currently Rust quizzes. Basically training Rust patterns to become better at Rust. The main goal is to decrease the friction between the intention and the execution. That's what I'm trying to aim for. And I'm just doing some quizzes now, and I'm gonna think about. I'm gonna discuss as well with ChatGPT how to improve the website to make the quizzes to make the environment better. And then I'm probably gonna have an agent to. I'm gonna use an agent to try to improve the websites. Similar quiz for C? I don't think so. Maybe there is. There's probably some website, but I haven't seen anything. This is confusing. Hmm. I guess the question is whether or not it's gonna. I think it has to call both, or like either it's choo choo or 1-1. I don't see why they're both calling it the same way. Or maybe yeah, because of the type, maybe. Yeah, maybe there is something about the compiler because the type is different here from here of the self. The question is which one is gonna match. I think for the first one, since they are the same, it's probably gonna call this one because it's more specific. I'm not sure though. Maybe not. I think it's the other way around actually. So because this type is the same here, I have no idea actually. Maybe because the type is the same here, then it uses this one instead of the normal implementation. And because the type is different here, is gonna. So I'm gonna guess that is 1 true. No, there's true 1. No, it has to be true then, because then this type would be different. But I think this obviously comes down to how the compiler is gonna. I think it's similar to the templates deduction on C++, where the compiler is gonna try to use the more specific one first, and then it's gonna like derive everything else based on that. So it's wrong. Okay, so the compiler is always gonna call the, which makes sense, I think, intuitively. It's always gonna call the direct implementation first. Only when the types are different, he calls the traits. I think this is an error because you can't, since you already have a reference here, you can't create another mutable reference because then you would have undefined behavior. Yeah, that's an easy one. I think I'm gonna stop here and I'm gonna start thinking about how to improve the website. Now, I'm not gonna consider this as done because probably we can improve this, but I'll do that another time. So this is what I wrote before. Because I was trying to think about like what are the main patterns that I want to train. Yeah, so I think that the best thing to do is basically transformations. That's what I should focus on. The question is, how can I Yeah, so the principles is like transformation and buffer manipulation, and maybe things for embedded systems as well. But then I think it's too specific. There has to be like core patterns that happen all the time, not specific to any domain. I think maybe I can expand to domains later. But then how this is another massive thing. I think how the compiler chooses to, which is just the last quiz that I did. There is basically exactly that. Is understanding how the compiler sees the language. So how it's gonna prioritize things. But more the motions or fundamental patterns. But typecasting is also another thing, which is from the other quiz as well, that says you can't downcast. So like the main problem is like how to go from 0 to 1. Because in order to know the fundamental patterns, in order to build quizzes to train the fundamental patterns, I need to know the fundamental patterns. Then it defeats the point. I think the first question is like, what is the best way to learn to find and extract fundamental patterns without having to spend too much time building, parsing, or extracting methods that would defeat the purpose. Because obviously the main thing to think about first is like studying the Rust analyzer, then using that, changing, modifying to do that, or using tree-seeder or another thing. But I don't want to spend too much. I don't want to drift into another thing. That's the problem. I think that there's two main focuses. Two main things. One is transformations. The other is compiler type checking, I think, or compiler resolution. Then there's also the ownership model. In lifetimes, I think it's probably not that. Like I think it is used, but it's not that high on this type of training. I think because lifetimes is probably gonna be a lot harder to do quizzes for this types of things. At this one, I already understand this. The macros as well. So what I'm gonna ask, let me think about what you Sure why line is not working there. I'll be right back. Mm. Now I don't remember if I deleted or if I changed anything. I think I'm gonna just push whatever.
Yes, I think the core idea is strong, and your existing website is already close to the right substrate. The thing I would change is the mental model. REST should not primarily be a quiz site. It should be a high-frequency REST execution gym. The optimization target is not how many REST concepts do I know. It is closer to how quickly can I translate an intended operation into direct REST without consciously searching for syntax, ownership rules, conversions, trade bounds, etc. That makes the design much clearer. Your current repository already gives you a good base. REST/Oxium server, SQLite progress, generated. Exercise manifest, categories/tags, and most importantly, a build system that already invokes a real REST compiler to validate exercises. GitHub plus one, so I would absolutely keep the browser UI for now. The fundamental unit should become a micro drill right now. Your quiz essentially contains code plus question plus answer plus explanation and quiz underscore type of compile. Stout text multiple choice. GitHub I would expand the conceptual model to something like drill source template task skill tags verifier difficulty explanation compiler artifacts. Important new concept is verifier. Instead of asking, is the user string equal to the answer, you increasingly ask, does this fragment produce the required program? That immediately gives you much richer exercises without needing to build a Rust parser. For example, imagine Rust double values, mud vec 32 whole task, double every value in place. Do not allocate another vec. You type Rust forks and values underscore mud x to the gym inserts that text into whole, invokes Rust, runs hidden tests, and tells you compile tests past 37 seconds 1. Attempt you don't care whether your answer exactly matches some stored solution. That's a very different training environment from a conventional quiz. The three major training systems I would build your notes already converge naturally onto three layers. Layer 1 your training example transformation intent right arrow Rust code vec t resolution predict what Rust means which foo gets called lowering slash execution understand what Rust becomes for right arrow iterate permission right arrow here I think these should eventually be literal top level training modes. Transformation training this is probably 70% of what will reduce your current friction. You're describing exactly the problem of knowing the transformation but not having the language motor pattern immediately available. You want hundreds of repetitions of things like vec t right arrow vec u mud vec t right arrow mutate in place vec option t right arrow vec t iterate item t right arrow option t result t e right arrow result u est right arrow result t parse error vec u right arrow string u right arrow encoded struct vec t right arrow flatten vec t and right arrow u and option result t right arrow result option t. You notice something important here. The transformation signature itself can become the taxonomy. Instead of organizing everything primarily by chapters like ownership iterator traits strings you could eventually represent knowledge as something closer to operation input mut t output intent mutate underscore each mechanisms iter underscore mut irrefutable underscore for underscore loop that's much closer to how programming actually feels. You have an object of type x. You want state y. What sequence of Rust operations gets you there? Build drill families rather than individual questions. This is where the density gets much higher. Suppose you make one exercise family called mutate underscore each. You can instantiate it as Rust mud vec 32 mud f32 mud point mud vec option node mud f32 44. Now you are repeatedly practicing Rust iter underscore mud. Forks and mud text field pattern destruct hearing but in slightly different contexts. Another family owned underscore collection underscore transform could force variations between Rust into underscore iter underscore mud map filter underscore map collect. This attacks one of the biggest sources of Rust hesitation directly. I know I need to transform this collection, but which ownership form do I currently have? That should become automatic. Close cards are useful, but I would use them carefully. Your first idea, create close card training, then extract logic from libraries is good. But I would distinguish recall close from production exercises. A close like Rust values underscore 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 x2 underscore 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 colon vec underscore is excellent for making names such as map, collect, iter underscore mud, as underscore ref, transpose, etc. Immediately available, but it should be the fastest here. Maybe 5 to 20 seconds per card. Production drills should then ask, given vec string, parse every valid integer and discard invalid strings, and give you an empty function body. The close builds lexical reflex. The production drill builds composition. You need both. I would make compiler prediction a completely separate training muscle. This is the part I think could make Rust forge unusually powerful. You shouldn't just learn to make Rust happy. You can train yourself to simulate Rust. For example, Rust trait if execute self trait if execute self struct x impl4 x execute self. Impl4 x execute self main let's x dot execute drill asks, what happens? A call to execute b calls b execute c whichever impl appear first. The ambiguous answer is ambiguity. Rust does not arbitrarily choose one. You can disambiguate with forms such as Rust execute x b execute x or the maximally explicit form. Rust assay execute x method resolution is more sophisticated than. Look at the type and pick a method. Rust builds a sequence of possible receiver types using AutoDiref, assembles inherent and trait method candidates, probes them, and then confirms the chosen candidate. If multiple applicable candidates remain ambiguous, compilation fails rather than choosing based on declaration order. Rust compiler development guide, so your intuition that compiler resolution itself should be trained is exactly right. A good compiler resolution drill could show Rust x foo and make you answer three things: receiver type, AutoDiref auto ref adjustments, final fully qualified call. For example, RC box t downward arrow diref box t downward arrow diref t downward arrow auto ref t and then Rust TAS some trait foo t that would build an extremely strong mental model. What does the compiler see? Could become an entire mode. This is where here THR mirror and friends become useful. A simplified Rust pipeline is roughly source downward arrow tokens AST downward arrow macro expansion name. Resolution downward arrow here downward arrow type inference type checking trait solving downward arrow THR downward arrow here downward arrow border checking your transformations downward arrow monomorphization downward arrow LLVM IR back downward arrow machine code. The actual compiler isn't simply one giant sequential pipeline. Rust uses an incremental query system where computations such as asking for an item's type or optimized near can depend on other queries. Rust compiler development guide here is already easier compared with source Rust. For example, for loops aren't represented as for loops in here. Rust compiler development guide THR is particularly interesting for what you want because it's typed and makes things such as method calls and implicit diff ranks more explicit before near construction. Rust compiler development guide in here is where things become much more mechanical. Control flow graph, basic blocks, locals, places, operands, values, terminators. Border checking operates using here. Rust compiler development guide that gives you a fantastic sequence of exercises. Rust source downward arrow. What does the syntax you super into? What types did the compiler infer? What receiver adjustment occurs? What does the simplified mirror roughly look like? Not every day needs drum here, but doing 2 to 3 of these a day could dramatically improve your compiler intuition. Salsa is slightly different from what you remember. You remember the right ecosystem, but slightly CONF related 2 things. Rust has its own query system, but Salsa is an incremental computation framework heavily associated with Rust analyzer and related compiler experimentation. The Rust dev guide explicitly notes that Salsa is inspired partly by Rust's query system, but is not itself directly used as Rust's query engine. Rust compiler development guide, so I would mentally separate Rust internals here type inference trait solver THR mirror border checker Rust query system Rust analyzer architecture. Incremental IDE computations also both are worth learning, but Rust internals are much more directly relevant to mastering language semantics. You can turn syntax sugar into daily compiler exercises. There is a massive amount of value here. You can repeatedly ask yourself to translate higher level Rust into something more explicit. X. Foo right arrow candidate lookup UFCS like call for X and collection right arrow into iterate next loop match AD right arrow add a EX index right arrow index mud closure right arrow compiler generated closure type captured fields. FNF and mud FN1's behavior async FN right arrow generated future state machine right arrow bowling of future state machine. Earlier term residual propagation machinery box TRCT right arrow direct candidate chain drop obstruct right arrow here. Drop blue match right arrow pattern exhaustive analysis control flow branches that creates a bridge between I know the syntax and I know what semantic operations the compiler must establish. That's much deeper. Form of fluency. Your existing website is actually better positioned for this than a browser only playground. This is important. Your UI may run in a browser, but your application itself is a native Oxium server. Your current builder already executes Rust through std process command. GitHub plus one, so you aren't actually constrained to WSM style Rust compilation. The browser can say post drill answer with exercise ID source entered in your native Rust backend can invoke the real locally installed compiler. That gives you access to Rust diagnostics warnings, compiler error codes, scout testing your different tool chains, nightly internals without leaving the website. For example, Rust's unstable near 2 link can dump here for selected functions and even graph have representations of the control flow/data flow graph. Rust compiler development guide plus one, so I wouldn't even consider VS Code yet. You can turn your current website into a front end for Rust. That's probably enough for a very long time. Here, extract patterns without writing a parser. Question I think the answer is, don't parse Rust initially. Make Rust your parser and verifier. For close cards, use explicit markers, Rust left result values. Pull xx2.collect, vec underscore replace the marker with the submitted text. Compile it. Done. For full function exercises, Rust console input, vec32, vec32 user replace user. Compile it against hidden tests. Done. For minimal fixed exercises, just accept the entire edited program and test whether the target compiler property changed. For type exercises, you can insert assertions into the hardness where practical. You do not need SIN, Rust internals, tree sitter, or an AST transformation engine to get 90% of the educational value. Where I would mine exercises, one extremely high value source is actually Rust's own test suite. Rust compiler repository contains thousands of small UI tests specifically designed to isolate things like Bora. Checking trait resolution method lookup coercions lifetimes generic type inference closures async const evaluation macros associated types. The UI test system intentionally consists of small Rust programs plus expected compiler behavior / diagnostics. Rust compiler development guide plus one that's almost exactly the dataset you want. You don't need to automatically ingest 20,000 tests. Have an importer that takes some test dollars and creates a candidate drill. Then you manually spend maybe 30 seconds turning it into questionable expected behavior tags explanation that is far cheaper than constructing sophisticated extraction logic. Interestingly, there was even recent 2026 research using a mask/close strategy over real Rust compiler test programs to generate useful compiler cases. The underlying intuition is very similar to yours. Preserve most of the real valid program in mask structurally interesting fragments rather than generating everything from scratch. AR14 I would reorganize your 17 topics into 4 training domains. Your list actually has a nice structure. Domain your topics data transformations vec/array loops, structs, conversions, matrices, strings, bytes, option slash. Result ownership plus representation scopes, closures, deref, casts, allocation, copy/move/drop compiler resolution traits, generic/where, match, macros, type inference execution models atomics, mutex, threads, futures/async. Then place compiler IR underneath all 4. Source level intuition, downward arrow, type level intuition, downward arrow, compiler representation, downward arrow, runtime behavior that is better than treating me as a standalone topic. One feature I especially want in this gym, minimal correction, give yourself broken code, Rust normalize XS, vec string forcing sprinkled. X sprinkled, XS then, goal, make this compile while preserving XS. Constraint, change at most 2 tokens. Now you have to immediately recognize, Rust forcing XS is extremely dense training. Another, Rust let value, use 64 something underscore I32 goal, compile without as. Another, Rust foo bar goal, disambiguate using trait B. These exercises force you to locate the smallest semantic operation required. That is exactly what turns compiler errors into intuition. Another very important mode, type tracing show, Rust let's vec. 1, 2, 3 let's xs.iter ex.map and 1 let's y collect, vec underscore ask, type of n, type of x, type of y, type of z. Later, Rust let's xs.iter underscore mut and repeat. Later, Rust xs.into underscore iter repeat. That one sequence trains, tt mut t into iter t iter t iter mut, a t map I f vec t. That is exactly the invisible layer that often creates friction when translating architecture into Rust. Measure the thing you're actually trying to improve. I wouldn't make accuracy the primary statistic. I would measure intent right word error first compiling attempt latency attempts until compile attempts until test pass compiler error distribution median solve time per pattern first attempt success rate and usage retention after. 13730 days suppose your dashboard eventually says iter underscore mut 9412 result propagation 8221 straight resolution 7134 lifetime 6349 byte conversion. 8817 associated types 5461. Now the gym can automatically construct tomorrow's session. That's much more useful than 143,200 questions answered. Your current handlers already track categories, tags, answered counts, correctness and mastery like information, so this would be an evolution of the existing system rather than a rewrite. GitHub, what I would actually implement next, I would resist adding 20 things simultaneously. I make the next version revolve around 5 changes. Add a code input/fill drill. User actually writes Rust. Backend compile/test it. Introduce proper skill tags such as vec underscore mut, ownership.move, trait, method underscore resolution, rather than relying mainly on broad categories. Record attempt count plus solve duration plus compiler error codes. This turns the app into a measurement system. Add minimal fix and predict compiler drills. These give you both execution fluency and compiler fluency. Add a compiler microscope button after answering. Source right word arrow, inferred explanation right word arrow here with your /thir style views later. After that, I build parameterized drill families. Only then would I worry about automatically extracting large quantities of exercises, because I suspect the bottleneck won't be having 10,000 questions. The bottleneck will be discovering the 300 to 500 extremely high value Rust transformations and compiler decisions that deserve thousands of repetitions. And that is a much more interesting problem. The deeper goal I think Rust Forge can eventually train 2 internal machines simultaneously. Your intent engine I need to mutate every element without consuming the collection. Rust expression downward arrow correct program immediately end. Your internal Rust surface syntax downward arrow names types downward arrow candidate methods downward arrow trait obligations downward arrow borrow. Relationships downward arrow lower control flow windows 2 in the middle. The phenomenon you're describing. I know exactly what system I want but get stuck on tiny Rust mechanics should shrink dramatically. And I think that rather than memorize Rust should be the explicit design criterion for every Rust Forge feature.
Yeah, I think that it actually makes more sense to spend time studying the libraries first. That's what I'm gonna focus now. Because the main reason why I was kind of more inclined to do the exercises first and to improve the gym is because then obviously you can build exercise, you can build exercise and become better as I study the libraries. And it's because I was thinking that maybe I could build something like a parser or something. Maybe this already exists. Ramel Tricitter is a famous library to parse. But I think that would make me deviate too much from actually learning, and then my concern is that I would be stuck trying to build a tool that parses the Rust to extract patterns, and I think it deviates too much. So it makes more sense to just compromise and then manually start studying the libraries, and then figuring out how to, as I study, how to ask questions or what to keep in mind as I'm studying to convert that into the intuition of what are the core patterns. Is also the thing that the core patterns have to be based on what I struggle to think about. Maybe one question would be, what would I struggle to come up with on my own when studying existing libraries? And what are the methods used the most? So what I'm gonna ask GPT is that seems that this whole thing was around the main paradox, which is In order to train the fundamental pattern, you should know what they are in the first place. I already have a bunch of libraries here that I put on a folder to study later. And I think that the Rust one here is the Rust compiler source code, or there's probably more stuff here. All the tools and other stuff like this. So the first problem is going to be compiling this. Figuring out how to compile so that I can go to the definition by pressing F12 on VS Code. So I think what I'm going to do, regardless of what GPT says, I'm going to spend time studying the Rusty compiler. I think I should spend like probably 80% of the time studying the compiler first and then asking questions around the compiler. It's more important to understand like how the compiler sees the language, so that I clarify the black box of what is going on underneath when I write the code. Then as I do that, spend around 20% of the time studying other libraries that I'm interested on, probably related to machine learning. Then I need to figure out a way, probably on the root heap repo, I create like a notes folder, probably. I can use LLMs, but then the problem is that it's not gonna be catered to what I struggle with, and it's also gonna be like it's not gonna be reliable. That's the issue. But I'm gonna use GPT to create a prompt for DeepSeek to read the source code and then like create a graph so that I know like what file should explore first. think about. I should. So this is the current libraries that I have here, and I should open on this. I think I'm gonna create a notes folder here, and just gonna keep markdown files, and then on the markdowns I use a notepad as I read to write down the questions, and I copy whatever I write to the markdowns. Then from those notes, I try to create the exercise from scratch. I think it's probably obviously much easier and better if I use agents and then I build. I'm gonna see if I can use GPT to build a prompt to then send to DeepSeek to build a graph of the best way to explore each file. Maybe I have, maybe I will do two graphs, one for the files and the other for the abstractions. That makes more sense. And I think hmm, the main thing I should focus on when studying that the Rust repo is gonna be to figure out, to clarify the parts related to the things that I can't see on the definition as I'm studying the other libraries. But maybe I'm thinking now that it's probably better to start off with the other libraries that ChatGPT said, is the core and the alloc, and then write down first the names of the implementations that makes more sense, because then I can go over the repo and then just search for the names and see if there's anything related to this, and then use agents as well. I'm thinking that probably makes a lot more sense. Let me see if I have this library. Because if I do, then it is on the same repo. Yeah, so I think, yeah, it's probably on the same. Interesting. Yeah, I think I'm changing my mind on this. GPT is right. Like I should, but I think I shouldn't start with these libraries first. I should start with these higher level ones. That makes more sense. I think I'm going to start either with an the array or an algebra and Kendo as well, and also this one which I think is a mathematics one. Because you start from the high level first, you see the actual implementation, then you figure out like what you're curious about, the patterns you're curious about exploring deeper, and then you go back to the alloc first, this libraries first, and then once I figure them out or clarify them, then I go bigger and go to the compiler. That makes more sense. And I think it probably makes more sense to open from this subfolder, open VS Code from the subfolder, and then try to figure out how to compile from there so that it doesn't cloud, like the other folders don't cloud the space. Need to switch to the nightly option, I think. Yeah, I think a better way is to first. I think what I'm gonna do is just discuss with GPT, discuss what order to study the high level libraries first. So I think that I'm gonna separate in stages. So go fast. I try to skim very fast all the high level libraries and just search for patterns that are common among all of them. Then write this to a notes. Then after I do that, then go over the core or try to compile the core libraries there. So I can go to the definition and then like write down more questions. Then do a second pass as after I have the questions to do a graph of like in what order should to study each library. That's the part that is very hard because I think that there's probably not a very good way to just do everything on quizzes because it's gonna depend. Like the hardest parts are gonna depend on the implementation, which depend on the architecture. It's not really a simple pattern, but I think that the like what I can compromise on is to create patterns for transformations on the built-in types. I think that's probably the best thing to do. So actually, something that I have to see on the libraries is what if they create their own types for manipulating tensors, for example, or these kinds of things, or if they use standard library types. That's the main thing. And once I have this, like what types are used the most, what libraries are used the most, what types are used the most, then I create like a list of these types. Yeah, probably that's the best thing to do. So first create a list of types that are used. Then, but maybe I should do I think I should do the order first. So like talk to GPT to clarify what order to study these libraries based on the everything that I'm building, the other projects that I'm building. Then once I have the order, then I go skim over these libraries, figure out what are the common types that they use, and common operations or transformations between the types. Then once I have that, then go over the Rust repo there, the core libraries, then try to compile them, then study them, then after that study the compiler. It's kind of like doing that for search, but on the study. So I go from high level to the bottom, then I backtrack to the high level again. And then I'm gonna have to either like on my memory or just write a bunch of notes to try to structure exercises that are gonna capture the transformations that happen all the time. I can do them like every day to just make it parts of my muscle memory. Yeah, from what I'm seeing on this one, it's probably not a very good one because it's gonna be more domain specific, I think. Maybe I should just look into the tensor implementation and stuff like this. Then write down. The question is, what should I write down exactly? And the issue is that like it's too much information. That's the problem. So it's too much stuff to read. I need to read fast. But I think that is gonna go back to the stuff that I said, which is that the hard parts are gonna be the things that depend on the implementation. So there isn't really an obvious way to like build quizzes based on this. I want to stop here. Then I'm gonna spend more time, not too much time, I think, off stream. So probably next time that I stream, I'm just gonna continue to go through this journey of trying to build. The main goal is to build exercises that are gonna help me decrease the friction between the intention and execution. And as I do this, I'm going to study the core libraries that are relevant to the stuff that I'm building. That way, I kill two birds with one stone. So I think probably next time, I'm just gonna do the stuff off stream of talking to ChatGPT and clarifying the like path that I should study everything and write questions. Then probably next time I'll start by studying one of the libraries that ChatGPT told me to study and writing the questions down. So yeah, see you next time.